Okay, so today's lesson's all about the quadratic formula and its parts. Okay, quadratic formula is nice from the standpoint of you will always be able to solve a quadratic equation with the quadratic formula. It will work every single time. You will always get an answer. Okay. Um, Factoring is better. If you can factor, you want to factor. If it's not factorable, I go to the quadratic formula. That's what I do. If I have to do it by hand and I can't factor it, I go to the quadratic formula. Now, some of the times you will have some problems that are solvable where you have to use the quadratic formula and they would have been factorable instead. On the test, if I say use the quadratic formula and it's factorable and you factor instead of using the quadratic formula, you will get a 0. This is one of those times where if I say solve using a particular method, you must use that particular method. Okay? Now, so the quadratic formula, I will have the quadratic formula up on the board while you're taking the test. So you don't actually have to have the formula memorized, but you do have to know how to use it properly. And I cannot tell you how many times I've had the formula not just up on the board, but I've actually put it on the test. Use the quadratic formula and put the formula in the question to solve the following. It's literally here, and here's the problem, and you're doing the work, and kids still don't do it right. It's frustrating when it's actually sitting literally in the question that's being asked. Here's the formula you use, and still don't do it right. Okay. Now the discriminant is part of the quadratic formula. It's the portion that is underneath the square root, but does not include the square root. And the discriminant does not actually solve the problem. What the discriminant does is tell us how many and what kind of solutions we have. That's all the discriminant does. The discriminant says, I have so many answers of what kind. And so if the discriminant, b squared minus 4ac, is less than 0, i.e. negative, so that means if I have the number underneath the square root's negative, I have two imaginary answers because the square root of a negative number is the imaginary number. And I have b minus b plus or minus an imaginary root. So it's b plus that, b minus that, two imaginary roots. If the discriminant is equal to 0, then I have one real root, and my real root is negative b over 2a. Because if this is 0, the square root of 0 is 0, I have negative b plus or minus 0, that's just negative b. So I have one answer if my discriminant is 0. If my discriminant is positive, I have two real solutions. Because I can take the square root of a positive number, and it's negative b plus that square root, negative b minus that square root to give us our two answers. What you need to understand with the discriminant, what you will be asked on your quiz, what you will be asked on your test, is not what my answers are. You will not be solving, you will just be using the discriminant to tell me how many of what kind of answers I have. You will find the discriminant, use that number to say, ooh, I've got two real, I've got one real, or I've got two imaginary answers. That's all it does. It doesn't actually give you the answers, it just tells you what you have. Okay? And sometimes, there are times, knowing that there is or is not a solution, hey, if there's no answer, I'm done. I don't need to go any farther. This is one of those things where you're kind of introduced to that concept, where you can find out whether or not you actually have an answer before finishing the problem. Say, hey, I don't have any answers anyway, so I might as well stop. Okay, and that's the idea behind the discriminant. Okay, any questions? Okay. So evaluate the discriminant and predict the solutions. The discriminant is b squared minus 4ac. Okay, so it's a, b, c. So this is negative 4 squared minus 4 times a is 1 times c, which is 4. So negative 4 squared, that's 16. 4 times 1 times 4 is 16. 16 times 16 is 0. So my discriminant is 0. My discriminant is 0. I have one real solution. I have one real solution. Same thing on the next one. So it's b squared, so it's 6 squared minus 4 times 3 times negative 2. 6 squared is 36. 4 times 3 is 12. 12 times 2 is 24. And then negative and negative, that means it's plus 24. What's your negatives and positives? This is where students get screwed up more than anything else, is not paying attention to their negatives and positives. 36 plus 24 is 60. This is a number larger than 0. So I have two real solutions. And I'm guessing you can probably figure out what the next one is, but we got to do it anyways. So what's my b on the last one? It's minus 1. My b is minus 1. Because how many x's do I have? I have minus 1x. So I have negative 1 squared minus 4 times 5 times 2, which is 1 minus 40, or negative 39, which means I have a negative underneath the square root, which means that I have two imaginary answers. One more than my imaginary friends. Okay. Questions? Your turn. Do those three. Okay, let's go ahead and do these. So it's b squared minus 4ac, so that's 6 squared minus 4 times 1 times negative 11, which is 36, plus 44, which is 80. So I have two real solutions for this one. Next one, I have negative 3 squared minus 4 times 4 times 2, which is 9, minus 4 times 4 is 16 times 2 is 32, which is negative 23. So I have two imaginary solutions. And then last but not least, negative 3 squared minus 4 times 5 times negative 2, which is 9 plus 40, or 49, which gives me two real. And so those of you assume that you were going to have one of each answer, you were wrong. Right? Because, you know, oh, 3 problems. I'm going to have one of each. Yeah, no. Questions on this? Remember, this just tells me how many answers I have. Doesn't tell me what my answers are. The discriminant does not give you answers. It tells you how many and what kind. It does not actually give you the answers themselves. Okay, next part. Reduce the following radical expressions. I am sure that you probably remember what quadratic formula answers look like. This. And you need to practice reducing them. One of the more common errors is not reducing and then reducing incorrectly. So, my first problem, or for my first step, simplify the radical if at all possible. If it's at all possible, you simplify out the radical portion. That's your first step. Square root of 9, that's easy. So I have 5 plus or minus 3 over 4. Now, if the radical portion disappears, like this, give me 2 separate answers. You have 5 plus 3 over 4, which is 8 over 4, which is 2. And you have 5 minus 3 over 4, which is 2 over 4, which is 1/2. Reduce it down to that. So 2 non-radical solutions. If this is the answer to your equation from using the quadratic formula, the problem was factorable to begin with if your radicals disappear. Second one, same idea. First step, simplify the radical. Square root of 4 is 2, but I also have a negative, which means that I have 2i. So I have 6 plus or minus 2i over 8. First step, deal with the radical. Next step, well, I can't break this down and I don't want to do 6 plus 2i over 8, 6 minus 2i over 8. I don't want to do that because I still have a radical in there, don't I? I technically is still a radical. So I don't want to split it into 2. However, if at all possible, I want to reduce my fractions. And I can. In this case, because all 3 portions, and it must be all 3 portions, have to be divisible by the same number. In this case, they're all divisible by 2. So if I divide them all by 2, this gives me 3 plus or minus 1i over 4. That's my answer. It has to be all 3 of them. It has to be all 3 of them, or it doesn't work. You can't just reduce parts. It has to be absolutely everything. It has to be divisible by the same thing. This is one of those ones when we get later on second semester, I'm really going to harp on. It has to be everything. It can't be just part. Okay. So the next one. I don't have an I. Woo, that's nice. I do, however, have square root of 12, which is reducible. 12. Square root of 12 is the square root of 4 times the square root of 3, which is 2 root 3. 4 times 3 is 12. Square root of 4 is 2. So this is 10 plus or minus 2 root 3 over 6. So that's my first step. Simplify the radical. If at all possible, simplify the radical. Second step, can I reduce my fraction? Yes. Everything is divisible by 2. I ignore the radical portion for this. I just look at the number in front. So I've got 10, I've got 2, I've got 6. 10, 2, and 6 are all divisible by 2. Divide 10, 2, and 6 by 2. And I get 5 plus or minus the square root of 3 over 6. And that's my answer. Oh, sorry, over 3. Thank you. My bad. My bad. Thank you. I was just doing that to see if you're paying attention. Right, yeah, you believe me, don't you? Yeah, no. I never believed my teachers when they said that, too. I had a college professor that said that. I'm like, really? We're all college students. You think we believe you? Yeah, nobody's perfect. I make mistakes. Everybody does. Okay. Next one. 7 plus or minus negative root negative 5. Square root of a negative, got to pull out the I. So I have 7 plus or minus I root 5 over 8. And that's it. I can't do anything else. If I got a negative, I pull out the negative root, make it an I in front. I can't do anything to the square root of 5, so it stays by itself. Okay. Can I simplify the radical? No, there's no negative, so there's no I to pull out. Square root of 13. 13, the only factor is 13, or 1 and 13. I can't reduce it, can't simplify it. That one's done. Yes. There might be. There might not. Let me finish this last one, then I'll address that in particular. Okay. So in the last one, simplify the radical. Square root of 24. 24 is, do it down here, square root of 24. Square root of 4 times the square root of 6, so that's 2 root 6. So this is negative 6 plus or minus 2 root 6 over 12. And I know a number of you are going, hey, everything's divisible by 6. No, not everything's divisible by 6. You cannot divide numbers inside and outside the radical by, you can't reduce inside and outside. Whatever's inside is inside, whatever's outside is outside. You cannot reduce something inside from something outside and vice versa. It's like in Vegas. Whatever happens in Vegas stays in Vegas. What's in the root stays in the root. Okay? So, but I can reduce this because everything else is divisible by 2. The 6, the 2, and the 12. So I'm getting negative 3 plus or minus root 6 over 6. And that's done. I cannot go any farther. Yes, it appears that they're all divisible by 3, but the 3 inside the radical cannot be reduced with things outside the radical. Now, before you move forward, I had a question. Will there be questions like this middle one here where there's no reducing on the test? It's entirely possible. This activity here is twofold. One, I may ask you a question straight up like this on the test, reduce it, but you also have to be able to reduce any quadratic formula questions you get. So if you're solving the quadratic formula, you get it down to here, you're going to have to reduce it. And they might be reducible, they might not. I don't know for sure. Okay? And it would not be beyond me to give you one that is not reducible or give you one that gets to that point. Most of them are, but you always check. Do those. Okay. So let's go ahead and do these. First one, square root of 4. That's easy. 6 plus or minus 2 over 10, which means that I get 6 plus 2 over 10, or 8 over 10, which is 4 over 5. And I get 6 minus 2 over 10, which is 4 over 10, which is 2 over 5. 4 over 5 and 2 over 5. Second one is 8 plus or minus root 12. Square root of 12, as we did earlier, is 2 root 3. So I get 8 plus or minus 2 root 3 over 6. 8, 2, and 6 are all divisible by 2. So I get 4 plus or minus root 3 over 3. Square root of 8. Square root of 8. Square root of 4. Square root of 2. So 8 is 2 root 2. So I get negative 12 plus or minus 2 root 2 over 6. 12, 2, and 6 are all even, divisible by 2. So I get negative 6 plus or minus root 2 over 3. Questions on those first three? Okay. Square root of 12 is 2 root 3. We've done that 3 times now. but I have a negative 1 there, so it's 4 plus or minus 2I root 3 over 8. I have the negative 1 in there, so I have to pull it out and make it an I in front. And you do it in this order. Put the number, put the I, put the radical at the end. Okay. These are all even. 4, 2, and 8 divisible by 2. So I have 2 plus or minus I root 3 over 4. The next one I can simplify. Although the square root of 13 is not simplifiable, I have a negative. If I have a negative, I've got to pull it out and make it an I. So I have negative 5 plus or minus I root 13 over 10. And that's my answer for that. And the last one, square root of 14. There's no perfect square. Goes what?
Could you not divide that one?
Nope. That's it.
Well, in order to be able to reduce it, you're probably talking about this, right? I have to have a 5 here as well. It has to be all 3. 2 of them don't count. So I look at the last one, 6 plus or minus root 14 over 10. Square root of 14 is the square root of 14. I cannot simplify the square root of 14. And because there is nothing in front, that's it. That's my answer. Inside the radical and outside the radical, I cannot reduce. And it has to be all 3 of them. Okay. Come on. There we go. All right, here we go. The fun part. Okay. So, solve using the quadratic formula. I know the first one is factorable. I don't care. Still going to use the quadratic formula anyways, because that's what the directions tell me to do. Now, when you're using the quadratic formula, and I've rewritten it here, it is also in your notes, do nothing on the first step except fill in the blanks. Don't try to change anything. Don't square anything. Don't change any signs. Just plug them in. The most common error students make when they use the quadratic formula is trying to simplify it down in their head as they're writing it down the first time. The first step, all you do is plug the A, B, and C into that formula. So x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. You will notice my first step, I did not change anything. I strictly plugged the numbers into the formula. I did not take the minus 4 and make it plus 4 to begin with. Students do that, and pretty soon they forget that it's minus b, and they put whatever b is there in front without changing the sign. If they start doing that in their head, the next one, oh, it's positive. It's always positive b. It's whatever b is. I just put whatever b is. I just put b down there. That's what they will do. They will lose the negative. I see it all the time. 20 years I've been teaching this freaking thing. 20 years I've seen the same mistakes. And they always come from trying to do it in your head first, rather than writing it down and then simplifying it. The students that write it down and then simplify tend to make fewer mistakes. Okay? Now I simplify it. And I don't do too much at once. So negative 4, that means I have 4, plus or minus the square root of. Negative 4 squared is 16. 4 times 1 times 4, minus 16 over 2. All I did was simplify it a couple of things. 4 plus or minus 16 minus 16, that's 0 over 2. What is 4 plus or minus 0? 4. So I get 4 over 2, which is 2. What is my discriminant? My discriminant is 0, and my discriminant is 0. How many answers do I have? I have 1. This is an example of my discriminant being 0. This is why when your discriminant is 0, you get 1 answer. It's minus b over 2 times a. That's what it is. Okay. Next example. Same idea. Plug in the numbers. And I'm going to move this one down a little bit for my first step because I need more room. So I do minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. The other mistake that students make very commonly is they don't put it all over 2 times a. They just put the radical portion over 2 times a. And often they will start like this, and then for some reason, that fraction bar tends to get smaller and smaller and smaller and smaller. Be careful with that. Because if you get down to the final answer, and the square root portion is the only portion that's over that's in the denominator or in the fraction, and the plus or minus is out by itself, it will be wrong. It's plus or minus everything. It's everything over 2 times a. Now I start to simplify. Negative 6 plus or minus the square root of 36. 4 times 3 is 12. 12 times 2 is 24. But it's plus 24 because I have 2 negatives there. Over 6. Be careful. If I have a minus and a negative for my A or my C, that becomes plus inside rather than minus inside. Common mistake, it's always subtract no matter what the sign is. Got to be careful about that. So I have negative 6 plus or minus the square root of 60 over 6. 60 is reducible. 60 is 4 times 16. So the square root of 16, negative 6 plus or minus 2 root 15 over 6. Because 60 is 4 times 15. Square root of 4 is 2, so it's 2 root 15. Right? Square root of 60, square root of 4, square root of 15, 2 root 15. And then everything is divisible by 2 in front. So I get negative 3 plus or minus square root of 15 over 3. And that's my answer. Because although all 3 numbers are divisible by 3, one of them is inside the radical and the other 2 are not. So it stays there. It's a lot of work for the quadratic formula, which is why if it's factorable, I'd rather factor than use the quadratic formula, because factoring is faster and easier, requires less work, less opportunity for error. But you'll notice, part of the reason I take a lot of steps is I don't do too much at once. I do one simple step at a time. I don't try to do a bunch of things all at one time. The fewer things you do in each step, the less likely you are to screw up. And then we'll do this last example. So minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Just plug it in. Notice I say it as I'm plugging it in. Keeps me remembering what it is. So I have 3 plus or minus the square root of 9 minus 40 all over 4. 3 plus or minus the square root of negative 31 over 4. 3 plus or minus I root 31 over 4, and that's my answer because 31 is prime and thus not reducible. But I do have to pull out my I. If I've got a negative, pull out my I. So you can see why we skipped this section and did the last one.
And then he came back, so we could have I as part of our answers. Okay. Questions? When you're doing the quadratic formula, plug the numbers in and work it out. Yes, it requires a lot of work. Don't care. It will work every time, even if it's imaginary answers. Okay. Do those. Oh, and the last one. It's tricky. Because what do you have to do? What do you have to have it as in order to be able to do this? Equal to 0. And it doesn't matter which one you move when you're using the quadratic formula. You're not factoring. Doesn't matter. You can move the x squared to the other side. Doesn't matter with the quadratic formula. It does with factoring, though. But it has to be equal to 0. Okay, let's do these. So the first one, minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I get 3 plus or minus the square root of 9 minus 16 over 8. 3 plus or minus the square root of negative 7 over 8, which is 3 plus or minus I root 7 over 8. Next one, same thing. So I get minus b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So I get negative 6 plus or minus the square root of 36. 4 times 2 is 8. 8 times 4 is 32. And it's plus 32 because it's two negatives over 4. Negative 6 plus or minus the square root of 68 over 4. 68 is 4 times 17. So this is 2 root 17. So negative 6 plus or minus 2 root 17 over 4, which means I have negative 3 plus or minus root 17 over 2, because I can divide them all by 2. And last one on here. I have to move the 5x squared over. 0 equals negative 5x squared plus 2x plus 3. And so I have minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I get negative 2 plus or minus the square root of 4 plus 4 times 5 is 20. 20 times 3 is 60 all over negative 10. So I get negative 2 plus or minus the square root of 64 over negative 10, which is negative 2 plus or minus 8 over negative 10. Square root of 64 is 8. So I have negative 2 plus 8, which is 6 over negative 10, which gives me negative 3/5. Negative 2 minus 8, which is negative 10 over 10, which gives me 1, which tells me it would have been factorable. If you get numbers with no radicals, it would have been factorable to begin with. Once again, you still have to use this quadratic formula anyways. Questions? And if you had moved, instead of moving the x squared like I did, you would move the 2x and the 3, you'd still get the same answer in the end. Still going to get the same answer in the end. Okay. So this one is using the quadratic formula and solve the solutions to the nearest hundredths. How many decimal places is the hundredth? 2. 2 decimal places. So basically what you do is you actually use your calculator to take the square root. That's all. That's all that is. Use your calculator to take the square root to 2 decimal places. You will still have 2 answers because you will have minus b plus the square root minus b minus the square root divided by whatever 2a is. You will still have 2 answers. It will be 2 decimal answers. I want to make sure you have enough time for your quiz, which you should. Let's go ahead and do this first one together. We'll do the first one together. So, set it up the same way. Minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I have 7 plus or minus the square root of 49 plus, because it's 2 of them, 8 times 3 is 24 over 4. So I get 7 plus or minus the square root of 49 plus 24, that's 69 plus 4, which is 73 over 4. And then you get your calculator, your favorite calculator, not your least favorite one. Where's my favorite calculator at? Where's my favorite calculator going? I'm missing my favorite calculator. Oh no. Ah, there's my favorite calculator. It was hiding. What's your favorite one? So, and this is what I do when I do this. I don't take the square root of 73, get that answer, and then do 7 plus or minus that. Here's what I do. I do 7 plus, and let's see, where's my square root key? The square root of 73 equals, and take that number divided by 4. And I get 3.886, which rounds off to 3.89. And then I do it again, going 7 minus the square root of 73 equals, divide that by 4, and I get negative 0.39386, which is 39. I go straight to using this at that point. I don't take the square root, write down that decimal, and then do plus or minus that decimal. I let my calculator do the work from here. At this point, I let my calculator just take care of it for me. Any questions? Awesome sauce. Okay, don't worry.